Hi, hope you all have had a great weekend. So this is the last section in chapter 3 that we just weren't able to cover before our test. We're going to talk about differentials. When we get in class Wednesday, I'm going to do a graph on the board to try to explain visually what a differential is. But right now, we're going to just learn some differential equations, differential form. Whoops. So differential equation is an equation that involves x, y, and derivatives of y. And this is going to feel like cheating, but we're going to be picking up with example 4, finding differentials. So if we have y equals x squared, so this is the function. We'll take the derivative, and then we'll write the differential. Instead of us going with y prime for the derivative, we're going to use the dy dx form. So the derivative of y with respect to x, because x is the variable that we're differentiating, it's 2x. And we're going to see when we get together on Wednesday that dy and dx are two separate quantities. And so you can kind of see this as just a fraction. And to get the dy by itself, you could multiply both sides by dx. You won't actually show that, but the differential form would be dy equals 2x dx. And what this is doing, it's setting us up for integration. With integration, we would integrate a function with respect to x. So it's just getting us used to writing things in that form. So example B, y equals the square root of x. Well, first off, you should write that in a friendlier form, just like we always do. And then the derivative of y with respect to x, this is power rule, so it's 1/2 x to the minus 1/2. And we're going to do two things at once. We will simplify this as 1/2 square root of x, and we put the dx at the end. Example C, y equals 2 sine x. So the derivative of y with respect to x is 2 cosine x. And now if you want to start skipping this middle step, and you just want to take the derivative and then put the dx in the end, that'll be fine. D part, we have y equals x times cosine of x. So I'm going to skip this different derivative part. I'm just going to say the differential of y is first times derivative of second plus second times derivative of first. All of this dx. So dy is negative x sine x plus cosine x, all dx. All right, last one. Y equals 1/x. Rewrite that friendlier. So the differential of y is negative x to the negative 2 dx. So the differential of y is negative 1/x squared dx. Or negative dx over x squared. Both of those are great. I think we'll go ahead and do example 5. Example 5, we've got y equals the sine of 3x. So this is a composite function where we have to do chain rule. Nothing changes though. The differential of y is just the cosine of 3x times 3. We just do the chain rule like normal, dx. So the differential of y is 3 cosine 3x dx. And very last one for tonight, example 6, y equals x squared plus 1 to the half. They've already written it in a friendlier form for us. So the differential of y is 1/2 x squared plus 1 to the negative 1/2 times 2x. We have a chain rule going on, dx. I don't need to add brackets on example 6 or example 5 because this is all a product. This times this times this. But example 4, when we did the product rule here, I had to add brackets and I didn't talk about it, but it's the differential of the whole thing. So this was a sum. So in order for that to be all one thing, I had to put it in brackets. So the last step would be to multiply these, not constant terms, but these first terms here together and get an x over x squared plus 1 to the half dx. All right, I'll give you 2 to try. Find the differential. And there you go. There's 2 for you to try. And I'll see you all on Wednesday.